Hello students, I hope you people are fine and I welcome you again in this PM class. Now we are going to solve this case OTQ and this case OTQ I have extracted from past exam paper from March 2019. It is the real past paper of ACCA paper PM and the name of the question is CARA company and the topic name is linear programming. And the topic name is what? The linear programming. Now let's move on. And it's a linear programming which actually deals with multiple limiting factors. When an organization is facing with multiple limiting factors, then multiple limiting factors are solved through graph, right? So let's first read out this question. Kara company makes two products, Seabag and heard of. These are the details. To make a unit, that means to make one unit, each product, each product, the following resources are required. Material 5 kg, 7 kg, labor hours 2 hours and 3 hours, machine 3 hours and 2 hours, right? So these are basically the resources which are being used. Fixed overheads are 300,000 each month, 300,000 each month. The contribution per unit is this. This is the amount of contribution. Let's move on. These are the details. Okay. We will have to read it. Just wait. This is for month 3, the graph which has been produced. Now in the linear programming, you are not supposed to draw the graph. It is already it will be already plotted in the question. Question number 1. What are the limiting factors in month number 1? The simple question is that what is the limiting factor in month number 1, right? So let's now move on. This is month number 1. Forget month number 2 and 3. Month number 1. The manufacturing manager is planning production volumes and maximum availability of resources for month 1, 2, and 3. So these are the resources available. These are the resources which are available, right? So how many units are there to meet the demand? The maximum demand. What do you mean by the term? The maximum demand is 4,000 units and 3,000 units of heard of. CARA company has a legally binding obligation to produce minimum of 2,000 units of heard of. This company has an obligation to produce minimum 2,000 units of heard of in each month of 1 and 2. There is no minimum production required in month number 3. So there are the 3 months data, right? So we have to deal with the data for the 3 months. So this is the minimum requirement and it is a legally binding obligation. That means it quite may be possible that there would be the contract with someone. Okay, so it's a legally binding agreement to produce 2,000 units of heard of. But the maximum demand is 4,000 and 3,000. Remember my words. Whenever you are supposed to identify the limiting factor, you used to consider maximum demand. Which resource is the limiting factor or the bottleneck resource? Which product is the limiting factor? The one which cannot fulfill the maximum demand, right? The resource which cannot fulfill the maximum demand. And it is called limiting factor, right? So that's a very much simple point that those resources are said to be the limiting factor which cannot fulfill the maximum demand. Now, we have to prepare the data like that way, the availability and the required. So if we can see that they are only talking about month number 1. They're only talking about month number 1 and let's make the table right away here. Let's say, for example, I'm just writing here that maximum. You understand that maximum demand is need to be considered. Yes, and the maximum demand is 4,000 and 3,000 units, right? 4,000 and 3,000 units. So here is CBAC 4,000 units. Heard of 3,000 units. That's the max demand. Okay, so that will be required hours. Available hours. Shortage. Okay, now if you can see that what are the resources, that is material, labor and machine hours. Material, labor and machine hours, right? So what is the material? What is the material? I'm just removing this thing. Maximum demand. What is the material? Material requires 5 kg and 7 kg. Here you go, 5 kg and 7 kg. So 5 multiplied by 4,000 and 7 multiplied by 3,000. That will be 21 and 20,000, right? So how many units are required? Just plus these two. So it's 41,000 hours are required. And what is the available? Available is 34,000. Labor available 18,000. You can see right away from here. Labor available is material 34, labor 18, and machine is also 18. Remember, you are studying the topic linear programming, and there may be multiple limiting factors, right? There are multiple limiting factors. Okay, so labor hours 2 and 3 is equal to 2 multiplied by 4,000. 4,000 are the maximum units. 3 multiplied by 3,000, and so 17,000. So first one, yes, there is a shortage. There is a shortage. The answer is yes. There is a shortage? No, because we required 17,000 and we have 18,000 hours. So there is no shortage. Machine hours 3 multiplied by 4,000 and 2 multiplied by 3,000. So again, there is no shortage. So the only limiting factor is material. The only limiting factor is raw material, right? So this is for MCQ number 1. C is the correct option. Good. Number 2. The production manager has identified that only limiting factor in month 2. Now they are talking about month 2. Month 2 is the labor hours, right? What is the production volume for heard of for month 2? Now please remember that now I am making the entire production plan, but the question is only asking for the heard of for month 2, only heard of for month number 2, right? But please ensure that you are supposed to take the data for month 2. So let's now move towards month 2. And in month 2, the labor hours are only 12,000, right? And the demand are 4,000 and 3,000. But you know one thing, when there is a legally binding agreement, or you can say when there is a minimum requirement. So first of all, you are supposed to solve the minimum requirement first. First of all, you are supposed to solve the minimum requirement first, right? The minimum requirement. And when you are solving the minimum requirement, that means you have to prioritize it. Now see that I'm making the entire production plan, but I will only have to answer about the heard of. Now this is production plan M2, I mean month 2. So there is CBAC and heard of. There is CBAC and heard of. I'm writing here CBAC heard of. So contribution per unit is given. Contribution per unit is given, and that is 250 and 315. 250 and 315. 250 and 315 is the contribution, right? Now let's move on. And labor hours are 2 and 3. 2 and 3 are the labor hours, because we have to now work on the contribution per limiting factor. Contribution per limiting factor 2 and 3. 250 and 315. 250 and 315. And direct labor hours are limiting factor. Direct labor hours are the limiting factor. That is 2 and that is 3. So what is the contribution per limiting factor? Press this divided by this. Contribution divided by limiting factor. And so when you are supposed to give the rank, that means prioritize. So you have to make it first and then you have to make it second. Why? Because you are supposed to take the contribution per limiting factor. Because you are supposed to take the what? Contribution per limiting factor. So now first first CBAC will be produced and then heard of. But there is a minimum requirement to produce heard of, right? So we will be making heard of on the top priority. Why? Just because of the minimum requirement. So legal obligation to make 2000 units. So making 2000 units of heard of first and then follow the ranking criteria for rest of the production demand. All right. So there is a legal obligation to make 2000 units first. Okay. So now we have to produce heard of first and then move towards the next. So what is the optimal production plan? Let's do it here. Let's do it here, right? So first of all, that is in month 2. We are talking about month 2, right? Available DL hours. Month 2. Available DL hours. How many hours are available? The hours available are 12,000. 12,000 hours are available. First, we have to produce 2000 units of heard of. So this is hours available, right? Just note it down. And we have to take the balancing figures. So first of all, we are going to make heard of. We are going to make what? Heard of. How many units? 2000 units. And it takes this 3 labor hours, right? So we are going to make 2000 units multiply by this 3. So that means 6000. Out of 12,000, 6000 will be consumed by heard of. So we will be left with 12,000 minus 6000. We will be left with 6000 hours, right? So second, now the second one. Second one is about CBAC. Now please note that there is a minimum demand to produce 3000 units of CBAC. So if I just calculate randomly 3000 multiply by this 2. So I need 6000 hours and I have already available 6000 hours over here. So yes, 6000 hours can now be used in order to make how many units? 3000 units for CBAC. So this is my optimal production plan. Now, what I'm not going to do it, I'm just doing it over here. And this is heard of. The units are 2000 units. And there are 3000 units. So that it will be easy for you to calculate the thing, right? So this is my optimal production plan. This is my optimal production plan, right? So I will have to produce these number of units. I will have to produce these number of units. That's a very simple point. So now let's move on. Exactly. Now we have to produce 2000 units of heard of. Congratulations. Now let's move on. This is the theoretical requirement. If a shadow price for month 2 is 125 per labor hour. Now, what is shadow price? Shadow price is basically a very simple thing. I think I should write it. What is the shadow price? What is the shadow price? When you buy one extra unit of binding constraint, when we will buy one extra binding constraint, when we will buy one extra binding constraint, there will be extra production. There will be extra production, right? Now, what is binding constraint? Binding constraint means the resource which is fully utilized. After the optimal production plan, when you are making the plan, actually you will be planning it in 2 months, three later on. But you are making the optimal production plan. So when you are making the plan, let's say for example, you are making a plan on a piece of paper and there is a production plan. And when you analyze that these resources will be completely utilized, these resources will be completely utilized. That is called the binding constraint, right? So what is the binding constraint actually? Binding constraint means, I guess I should write it over here. Binding constraint, that is 100% used resources after the optimal production plan. After the optimal production plan, right? So this is basically called the binding constraint. So when we will purchase one extra binding constraint, there will be extra production. And then there will be extra contribution. There will be extra contribution. Now, from the optimal contribution and the extra contribution, the difference, the increase in contribution is called the shadow price. And the increase in the contribution is called shadow price. Increase in the contribution is called shadow price. Shadow price. Now, what is the increase in the contribution? There is the existing contribution. Just take the random figures. Example. Contribution at optimal point. Now, let us say contribution at optimal point is, let's suppose it is $5,000, right? So when you will purchase one extra binding constraint, so obviously the contribution would be increased. Increase contribution after buying binding constraints. Now, let us say, for example, if it would be 5015. Let's say. So how much is the increased contribution? So increase in contribution is $15. And this is called the shadow price. Shadow price, or you can call it dual price. Now, what is this shadow price? Please see that this is the shadow price or the dual price. That means that when, when you will purchase one extra binding constraint, that when you will purchase one extra binding constraint. Now, let's say, for example, in this case, it is talking about the labor. Let's say this is talking about the labor, right? It's talking about the labor. So if the shadow price is 125, okay, now let's make it 125 so that it will be easy to explain. Okay. Let's say this is 125 and connected with this scenario, right? This is 125. So this is called 125 per labor hour. So what does it mean? It means that when I will acquire one extra hour, one extra, not the normal available hours. When I will acquire one extra hour, I will be earning 125 extra. I will be earning 125 extra. I will be earning 125 extra, right? So the point to be noted is that when I will be earning 125 extra, so that means I can easily pay. This is the maximum amount. This is the maximum amount which can be paid to acquire one binding constraint. So what does it mean? It means that $125 per hour, 125 per hour, it is the increase in contribution by, it is the increase in contribution by having one extra hour. It is what? It is the increase in the contribution by acquiring one extra hour, right? One extra hour, 125 per hour. Now, second point. This is the maximum amount which can be paid as a premium amount, which will not be. Obviously, in actual, you will have a bargaining and you will be paying less. But this is the maximum amount which can be paid, This is the maximum amount which can be paid. This is the maximum amount which can be paid. So got that point? This is the maximum amount which can be, which will not be, which can be, which can be paid as premium. I mean, you can call it overtime premium to buy one extra hour. So right, so this is actually, this is not only in the case of labor, this is in the case of material as well, that this 125 is the shadow price, and shadow price means that this is the maximum amount which can be paid above the existing rate, right? So just see that number one point, what has been written over here? What has been written over here, that is the production manager would be willing to pay existing staff a maximum overtime overtime premium 125. The statement is correct. It's not the normal rate, it is the increased rate. Number two, the production manager would be willing to pay maximum 170 per hour for additional 2000 hours, maximum 170. Now, how do we calculate 170? Let's move above. The existing rate is $45 per hour. So $45 plus 125 is equal to 170. So the statement number two is also correct. Right? So what does it mean? That is 45 plus 125. So that will be 170. This is the maximum total amount. So yes, both options are correct. C is the correct option. So please note that What is exactly the shadow price? The shadow price is the increase in contribution. The shadow price is the what? It is the increase in contribution by purchasing one additional unit of the binding constraint. So for that, you must need to have the background knowledge of the binding constraint, that what is this and what is not, right? So this is my MCQ number 3. Good. Okay, so now let's move on to the next question. And the next question is, what is the maximum amount? The next question is, what is the maximum profit, maximum amount of profit which can be earned in month 3? They are asking the maximum profit which can be earned in month number 3. Now, how do you calculate the profit? Simple point is that you have to calculate the profit, that is contribution minus fixed cost. Contribution minus fixed cost is actually the profit figure. So this question is just focusing on month number 3, that what is the maximum profit which can be earned. Okay, so let's now move on to the month number 3 data and see that in month number 3, this is the month number 3 data. The following linear programming graph has been produced. Now, linear programming, you know that this line is called the ISO contribution line. Now, do you remember the function of ISO contribution line? You have to place the scale on it and you have to move it in the upward direction. You have to place the scale on it and you have to move in the upward direction. Right? So when you will move on, this is the linear programming. And when you will be moving on, so this is the point which seems to be the optimal production point. Why the optimal production point? Because you have to identify the constraints. You have to identify the constraint. Now, first of all, let's see that this is H300. H300. Now let's move above. H means heard of. This is the maximum demand. Maximum demand means you cannot produce more than 3,000 units. So that means it is H less than 3,000. So that means the feasible area, you know the feasible area is the one which is bounded by all the constraints. You know that there is the feasible area. There's a feasible area which is bounded, which is surrounded by all the constraints. Which is surrounded by all the constraints. So when there is less than, you have to see the left. When there is greater than, you have to see the right. When there is greater than, you have to see the right, right? So that's a very simple point. So this is H 3000. That means you have to look down. So you have to look it down. Okay. So, and this one is 24,000. The resources, because you are not having more than 24,000 time. You are not having more than 24,000 labor hours, not more than 35,000 kgs, not more than 12,000 kgs. So what does it mean? That means it is also reflecting less than, it is also less than. So all the areas, you have to look it down, and this is also less than, you have to look it down, So this is the area of feasible region. And this point is the optimal production point. This point now, and this is the ISO contribution line. See that this H3000 and this line, 3H, 3S, 2H, 12,000. This is the optimal contribution point. Now, mathematically, you have to calculate these two equations in order to identify, in order to determine the optimal production point, right? Let's now move on. So this is the point which I have just highlighted, giving it name A. So A is the intersection of two constraints. I'm just writing it over here. That is point A. Point A, intersection of. It is the intersection of H 3000, number one. It is H 3000, and number two is 3S 2H 12,000. This one, 3S 2H 12,000. 3S 2H is equal to 12,000. This is number two. So you have to solve it. You will be calculating the you will be calculating the number of units, and then minus fixed cost is equal to profit. That's a very, very simple point. Okay, now let's move on. I'm solving it right away here. This is my MCQ number. Oh, sorry. This was MCQ number 3. And this is MCQ number 4. This is intersection of H 3000, H 3000. Just wait a minute, please. This is H is equal to 3000, and 2S plus, it was, sorry, 3S. 3S plus 2H is equal to 12,000. Right? So this is the intersection of number 1 and number 2 equation. So what is the mathematical formula? You have to place H in the equation. Now it will be solved like that way. Let me simply do this thing. This you have to place it here. So you will be able to calculate the things. Right? So what I'm just writing it over here. Place H is equal to 3000 in equation number 2. So what will be the thing? How you will be calculating like that way? 3S plus 2 multiplied by H is 3000 is equal to 12,000. So how do you calculate S now? You have to compute S. Now see that what will be the mathematical way. This 3000 multiplied by 2000. Okay, let's make it far more simple. Now this will be 3S plus 2 multiplied by 3. That is 6,000 is equal to 12,000. So how do you calculate S? Press is equal to 12,000 minus 6,000 divided by 3. So that is 2,000. So what is the optimal point? What is the optimal point that you are making? This is my optimal production plan. So this is my optimal production plan. See back 2,000 and head office 3,000 units. Calculate the contribution minus fixed cost, you will receive the profit. So now what is the contribution over here? Contribution is given. It was 250 and 315. Okay. 250 and 315. So what is the total contribution? What is the total contribution? Price is equal to this multiplied by this. This multiplied by this. So the total contribution is, oh, it was 215, sorry. So the total contribution is this one plus this. This is my total contribution. It's 215 and, oh, 250 and 315. Sorry. 250 and 315. 250 and 315. Sorry. It's 250 and 315. It's my total contribution less fixed cost. And the fixed cost is 300,000. This is my fixed cost. You can see that fixed cost in each month. Fixed cost remains fixed. This is 300,000 each month. This is the fixed overheads. So my fixed overheads are 300,000 and my profit would be, this is my answer, 1145,000. 1145,000. And that is D. So this is the correct option, that is D. Okay, now let's move on for the MCQ number 5. And again, it is a theoretical in nature. And okay, which of the following interpretation of linear programming graph produced for month 3 are correct? Now, please see that there is a very simple rule. When you are making the graph, now let's say, for example, this is the graph, right? And this is the resource line labor. And this is the resource line, let's say direct material. Material and labor. Now, let us say, for example, material and labor. And this is the optimal point. This is the what? This is the production point. This is optimal point. Optimal point. What I'm now trying to explain to you people that what is the production point? This is, so the production point in this case is the intersection. It is the intersection of direct material and direct labor. Please note and follow the thing. When any resource is on optimal point, that is the binding constraint. That means it is a symbol that the resource is 100%. This is a symbol that this resource is 100% utilized. The resource is what? 100% utilized. The resource is 100% utilized. That means the resource is 100% utilized, right? So here, for example, I am drawing this line, and this is the line of machine hour. This is the line of what? Machine hour, let's say, for example. So any resource, please focus on the word, any resource which is outside above optimal point, that means the resource is still available. The resource is still available. What does it mean? It means that when the resources are available after the optimal production point, that is called the slack. That is called the what? Slack. So any resource, I'm just typing it over here. Any resource. Okay, first slack. First slack. What is slack? Slack is what? Any resource which is available more which is available more after the optimal production. That is unused resource. Unused resource, right? Number one. Slack means this thing. One more thing. If there is demand, now let's say, for example, if there is demand, now I am making the graph, I'm making one more graph, and that is, let's say, for example, this is the demand of X. Demand of X. Now again, let's say, for example, this yellow color represent 1,000, and this is my optimal production plan, and that is, let's say, 800. So optimal production plan is 800. First of all, I'm just explaining in the concept of graph. So what is the optimal point? Optimal point is 800, right? But the maximum demand is, and the maximum demand is 1,000. So that means after satisfying the optimal production plan, there is a still demand left. So this is all. So this is also called the slack. So slack, one more point. What is slack? One more point, that is slack. Number one is any resource. Number two, any demand which is still unfulfilled. Any demand or I should say that any demand, you can call it any maximum demand, which is still unfulfilled. So, how to identify the slack on graph? Slack is anything that is unused resources or unfulfilled maximum demand. And the indication from graph is that it is always outside, above optimal point. So slack is what? Above optimal point. This is the slack. This is the identification of slack. Now there is binding constraint. Binding constraint. And I have already taught you above the binding constraint. Above you can see that what is a binding constraint and where do you find binding constraint? It is on. It is on the optimal point. It is on the optimal point on the graph, right? It is on the optimal point on the graph. So binding constraint is what? It is the 100% utilized resource. Binding constraint is not the demand. It is always of resource. That is 100% utilized resource. So it is on the optimal point. Please remember this thing. This is a very simple indication to identify slack and the binding constraint. Now, in graph, we have to study the graph. We have to read the graph. Please see that this is the graph for month 3. And month 3, this is the 3S and 2H. 3S and 2H. This is the machine hours. So this is basically the line of machine hours. And this is the demand for heard of. It is a line of machine hours. It is a line of machine hours. It is a line of machine hours, right? So the line of machine hours and the line of demand. Line of machine hours and the line of demand. So what is written over here? All the other things being equal, unless demand increases for either the product, labor will be a slack variable. Labor will be a slack. Now please note that what is the line of labor? You can see that labor is 2 and 3, and labor is available 24,000. Okay, this is labor. This is labor 2, 3 and 24,000. So yes, it is a slack because it is outside, above optimal point. So labor equation is yes, above optimal point. This is the optimal point. So this is outside. Yes, this is a slack. This is a slack. Point number 1 is correct. Number 2, if more machine hours were made available in month number 3, they would be used initially to make heard of. If more labor hours, that means more labor hours. Please see that you have to connect it with the above. What was the maximum demand? What was the maximum demand for heard of? We have already produced it in month number 3. In month number 3, you have already made the production plan. Please see that you have already made the production plan in month number 3. Month number 3, heard of is 3,000 already made. So the maximum demand is fulfilled in month number 3. See that this is MCQ number 4 for month number 3. So in the above MCQ, we have already made 3,000 units, and 3,000 units of heard of is the maximum demand. So if this machine hour, please see that this machine hour is the binding constraint. This machine hour is the binding constraint. Why this machine hour is a binding constraint? Because it is on the optimal point. It is on the optimal point. So machine hour is the optimal, it is the machine hour is the binding constraint. Machine hour is the binding constraint in month number 3. And it is already produced 3,000. So I will not be producing heard of. I will be producing C back. If more machine hours would be available, I should have been produced the C back, not the heard of. So this statement is wrong. Only A is the correct option. So if more machine hour will be available, Instead, we would be making CBAC. All right. No heard of, because heard of has been already produced. So yes, this is the case OTQ from the topic of limiting factor and the linear programming, right? So this is the thing. We have successfully completed this thing. Good luck. Congratulations. See you in the next video. Take care. Bye bye.